Welcome to Brain Vision.
Okay, in this question, we have a hydraulic cylinder system. It's a little complicated with a 12-inch long bar that's connected in the middle by a 6-inch long bar. At one end of the 12-inch bar, it's connected to a hydraulic cylinder that will raise it up or down in this case. And then the other end of that bar is free and will slide to the right. So we want to find the velocity of C here as it moves to the right. So we'll have to use a little bit of geometry here. So first, we're going to look at this sine of theta and try to come up with a nice way to look at this. And to do that, we need to know that the vertical side of this small triangle down here, so what I'm going to highlight in red is the vertical side, will be half the height of point A, which I'm calling the total height there is S. So half the height is just S divided by 2. And divide that by the hypotenuse of that triangle, which is just B. So that's S over 2B will be our sine of theta, which we can rewrite that for S. So S equals 2B times the sine of theta. Then we can take the derivative with respect to t of both sides. So we have S dot equals, B is a constant, so that is outside of our derivative. Time derivative of sine of theta will just give us the angular velocity omega, or theta dot, whichever way you prefer to write it, times the cosine of the angle theta. Then we're going to want to rewrite the cosine of theta in terms of ideally x and b again. So in this case, it'll be the adjacent side, which I'll highlight in green down here. So that's just x over 2 divided by the hypotenuse b. So this will be x over 2b. So that's pretty convenient. We can then rewrite x as x equals 2b times the cosine of theta. So it looks very similar to our s at this point. And again, we take the time derivative again. This will look very similar. We have x dot, which will be our velocity in the c direction, equals 2b times omega again. But this time it'll be times the negative sine of theta if we take that time derivative of the cosine of theta. So we can do a little bit of algebra here then and take our equation for VC and divide that by S dot. So we have VC over S dot equals, VC was negative 2b omega sine of theta. Divide that by S dot, which was 2b omega cosine of theta. Well, the 2b omegas cancel out. That's great. And we're left with VC equals negative S dot times the tangent of theta. And if we put all the numbers in for this, we find that we get a negative 2.38 inches per second to, so that means it's moving at 2.38 inches per second to the left.